first is a concept that you'll need in addition to the ones we started lecture with, and then we'll talk about stem cells. So today, we'll talk about potency, and then we'll talk about stem cells. Potency, along with fate, determination, and differentiation, is one of those terms that you need to know and you need to understand in order to understand stem cells. Potency refers to the number of possible fates that a cell can acquire. Number of possible fates. Open to a cell. And this is a very important concept of development because, in general, potency decreases with age and decreases as different parts of the organism become specialized. So in general, potency decreases with age but I will put in here, and we'll explore this more in a moment, except for some stem cells. And we haven't defined a stem cell yet, but we will. What kinds of potencies are there? There's the big one, totipotent, where a cell can become all fates. And there's really only one cell that can do this in the normal animal, and that is the zygote. And in most animals, even as the zygote becomes just 2 cells or a few cells, that full potency is lost. And cells instead in the embryo are multi or pluripotent, which means that they can acquire many fates, but not all fates. Embryonic cells, especially in the early embryo, and many stem cells are also multipotent or pluripotent. And then as time progresses, is that a hand up? Yes, sir.
Reconcile that with the fact that human cells, separate them, even up to the meat cell stage, they can make
That's a great question. The question is, how do I reconcile what I'm telling you with the fact that you can get identical sextuplets or octuplets? Actually, it's a good question. That's true. In different animals, the very early embryonic cells are sometimes totipotent up to a while, okay? And so, for example, in armadillo, here's a piece of, fact for your back pockets. In the armadillo, the 8-cell embryo almost always splits into 8 single cells, each of which becomes a baby armadillo. Okay, so those cells are totipotent. In mice, even at the 2-cell stage, the 2 mouse cells are probably not equivalently potent, and they're not totipotent. So you very, very seldom, almost never, get identical mouse twins. Okay, so it's, it's one of these generalities, and if you ask me, you get the specifics are a bit different. As cell fate restriction continues, cells can become bipotent or unipotent, whereby 1 or just 2 fates are open to them. And so if we look, taking this concept, let's now start the lecture about stem cells. You're going to need this concept. Stem cells, I'll point out, whatever they are, got almost 3,000 hits yesterday on Google News. This is way below baseball, which got 45,000, I checked. But still, as science topics go, stem cells are really up there. and they're on the covers of magazines over and over again. And we'll talk more about why that is. Here's a diagram. It's not on your handouts that I drew for you. Let's not dwell on it. But let's now move on to topic number 2, which will fold in this concept of potency and the concepts of fate, determination, and differentiation.